All right, guys, so we're starting chapter 1 today, 1.1. Now, what we're going to be covering in here is mainly going to be what we consider what is called Euclidean geometry. Guys, so what we're starting today is chapter 1.1. Now, everything we're going to be covering here in geometry is what we consider Euclidean geometry. Now, there's basic types to it, and we won't really delve too much into kind of really going into why it's considered Euclidean geometry. We may if we do have extra time, but what we're covering will be considered under the classification of Euclidean geometry. Let's go to the next page. So all of these here are different subcategories in Euclidean geometry, or stuff that we would consider a part of Euclidean geometry. So all of these things here. So let's close the Chromebook. Thank you. All these here are considered Euclidean geometry, as well as all of these here. All of these here are different types of Euclidean geometry. Now, we're not going to delve into all of them, especially a lot of 3D projections and stuff like that, or nth degree or nth dimensional Euclidean geometry. We won't really cover that, but this here is all the different types of Euclidean geometry that there are. Now, if there's Euclidean geometry, there's also non-Euclidean geometry. And here I'm just really wanting to show you, because the geometry as of itself doesn't seem like it's something that's a big topic, but it is huge. All of this here is non-Euclidean, and then we also have other types that don't really consider either one. So there's a lot in geometry, and that's really just what I wanted to show you guys, and so that you can see geometry is more than what we're just going to cover in here. There is more to it. Now, the first three things we're going to talk about here in 1.1 is point, line, and plane. A point has no dimensions. A dot representing a point. A dot represents a point. It is considered really a location. A spot on a line. A spot on a plane. It is a location. And it is considered one of the three undefined terms. Point, line, and plane are all three considered to be an undefined term. And we did have these down in the definitions. You did see these before. So by this definition, can anybody make a point on their paper?
I think so.
So go on and make it on your paper. So that there we made a point, yes? And by definition, a point has what? No dimensions, which means it does not have a length or a width. So the point on your paper, could we take a ruler and measure its length and width? Well, yeah, because when I draw a point, even this right here, I could take a ruler right up to it and say, well, that's about a ½ inch, right? Because any time we put pencil to paper, the dot that's created does have a width and length. But by definition, a point has no dimensions. So it's more of a thought construct, because we can think of a point, we can conceive of what it is, but anytime we try to make one, we give it dimensions. Because as soon as we draw it, it has a length and width. That is why this is considered one of the undefined terms. We know what a point is, we can think of what it is, but we can never actually create a point. Because once we create it, we give it a length and a width. We give it dimensions. So it doesn't work. We can't actually have a point created, but we know what it is. We know what we're talking about. And when we talk about it, we can call it point A. Now, line is the next one. A line has one dimension. Now, you don't have to write this entire thing down, because, again, we know what a line is. Straight line passes through 2 points. Yes? Now, the key thing to get is how we name it. Whenever we name a line, we use any 2 points through the line. Any 2 points on the line, we use it to name the line. So for this here, this line, AB, we can call it AB or BA. I'm going to draw it again or write it again so y'all can see it a little bit clearer. But whenever we name a line, we're going to use any 2 points on the line. Now, one of the big things with this is we need the line above it. We need to have the line above our 2 letters, AB, BA. Because if we don't have that, especially if you're taking the quiz or test, I will count off. I will count off for that because that is part of the definition of a line. How we name it. We have to have that. Now, we could use this little L. Let me get just right here. We could use that to be able to name it. It finally catches up. See if it'll do anything. Thinking. No. But if we use that, we'll just call it line L. And normally if we're naming a line based off a single letter, it'll be at one of the 2 arrows, and it's always lowercase, if we know that it's that. For most of the points, for all the points, it'll all be capitalized. Points on a line will normally be capitalized. Now, again, this is an undefined term. And the reason it is undefined because a line does what? So it extends without end. So it continues on indefinitely in 2 directions. Well, could we ever fully draw a line then? No. We know in our heads, okay, it extends without end, goes indefinitely, but we can never fully create a line. So we can't make a point. We can't actually make a point. We can't make a full line. That is really kind of why they call these undefined terms, because we can't really make them. We know what they are. We have an understanding, a concept of it, but we can't actually physically make them. So any questions about point or line? We ready to look at plane? A plane is essentially as if we take a line and extended it and gave it a width, we would consider that to be a plane. It is represented by a shape that looks like a floor or wall. Now, when we name a plane, we name it by any 3 points on the plane that do not make a straight line. We name it by using any 3 points on the plane that do not make a straight line. So here we can call this plane ABC. We could call it plane CBA. Or we can call it plane ACB. Or plane BAC. Any combination of these 3 letters will work. Bless you. Any 3 combinations of those points would work as long as they're not on the same line. As long as they are not on the same line. If they are on the same line, we cannot use those 3 points to name the plane. Now, 2 of the points can be on the line as long as the 3rd one is not. So we'd have 2 on a line, 1 off. That still works. Now, they will sometimes give us here M, the M in the corner of that plane. We can use it to name the plane because it's not actually attached to anything besides the plane. So we could call this plane M. Any questions about point, line, or plane? Okay. Now, before we get to our next example, we do have 2 other things to look at. Collinear and co-planar. Collinear, co-line, linear, line, means that we have 2 or more points that lie on the same line. Points are collinear if they are on the same line. Co-planar are points that lie in the same plane. Plane, co-planar, plane, same plane. Co-linear, linear means line. Co-linear means that points that lie on the same line. Co-planar is points that lie on the same plane. Any questions on this here? We good with collinear, coplanar, line, point, plane? Okay. Let's look at our first example. So this should be line. I don't know why it cut that off. PQ. So what is another way that we can name, bless you, line PQ? Well, line PQ is right here. So that's another way we can name it. QP. And again, since we're talking about a line, we have to have the symbol for a line above it. All right. We need one more because we want two. We found one. We need to find one more. There's another way we can name it. So we can use the N, but it would just be line N. Because anytime we have the lowercase at either end, we can just say line N. We can use that one letter to name the line. And that's it. So we have the two ways to name the line. Switch utensils. So any questions about how we name the line in those two ways? And we'll get more into naming lines and planes here in a minute, or more about naming lines here in a little bit. So plane P, or plane R, sorry, plane R. Plane R is this plane right here. And we want to give two names for it. Now there's more than two. But what would be one way that we can name this plane? SVT. So we can call this plane SVT. That works. Can someone else come up with another name for it? So we could take TP, but I wouldn't use S. V. We need 3 points, but they can't be on the same line. So TP, V works because V is off the line. It doesn't matter that T and P are on the same line. The third one has to be off. So we could, we can keep going. Plane V, what? So R would be the whole plane. So we couldn't use it, and we can't use M because M names the line. VPS. We can just use those 3 letters over and over and over again. What is one letter we cannot use for this plane? Q. Because where is Q? Above the plane. It's outside the plane. So we can't use Q, but we could use any one of these 4 here. The big R in the corner is naming the plane itself, but the reason we don't use it is, well, they gave it in the question. Name 2 other ways to name this. So I'd pay attention to that, especially on the test. If I say give 2 other ways or name 2 different ways to name the plane R or to name line PQ, and you use PQ or use that in the answer, I won't count it for part of your answer because it's not another way to name it. So we have these 3 here. Any other questions on naming a plane? Okay. Let's look at part B. Part B. Name 3 points that are collinear. Collinear means what? Same line. So what are 3 points that lie on the same line? Yeah. S, P, and T. They lie on the same line, so they are collinear. Okay, now it asks us to name 4 points that are co-planar. So this is collinear. Co-planar. Okay, so I heard SP. So what does coplanar mean? Yes. Points that are coplanar lie on the same plane. So S, T, P, and V are all on the same plane, so they are coplanar. N, M names the line, so it's not an actual point. So M is just naming this line here. And R is just a way to name this plane. Any other questions on this here? Are we good with this here? Yes? All right, let's look at the next one, the next problem. So this may be on the next page. So there are 2 parts to this one here. So the first one is we want to give 2 other names to line ST. So they told us we're looking at ST, but we want 2 other names for it. Yes. Line M. That works. PS would work. Let's go on and see if we can find all of them, because there's a few. There should be 4 more. PS, well, if considering that, there'll be a few. Because we have TS, ST, PS, PT, SP, DP. So we have ST, SP, PS, PT, TP, TS. So that's it. So with 3 points and a letter naming it, we came up with 5 others because they gave us 1. So there's 6 total, plus our line M. So at 3 points, there's many different ways to name the line. Now, this works with lines because a line does what? It extends indefinitely in 2 directions, yes? So no matter how we name it, if it extends out through those points, it will cross every single one of the points. So it really doesn't matter how we arrange this, what letters we use along the line. We can use any 3 of these. And if you notice that line M or line ST or any way we named it doesn't extend outside that plane, the entire line is contained inside the plane because the plane itself extends indefinitely in all directions. The line extends indefinitely in all directions. It will be contained. Now, line QP, as we can see, is drawn intersecting the plane, so it actually extends outside of the plane. Okay. Any questions on this here so far before we look at the next part? Okay. Name a point that is not coplanar with Q, S, and T? It would be point V. Because when we look at this here, really what we're saying and what we're creating is this plane here. It's not drawn in, but where that line, QP, goes up and down, we just created a plane there. So even though it's not drawn, we can visually or mentally think about this plane here, and well, point V over here is outside that plane. So V would be the correct answer for this too. So not coplanar to Q, S, and T is V, or however you want to phrase it, and know what we're talking about. Question? Confused? I mean, I'm just writing away so that we know that V is the answer to the second part. Any questions on this here? Do we understand why V is not contained in the plane?
No. Because it's for R.
Let's do it in a little different way. I'll need two of these. And okay. Need to start that back up. If there are no other questions on that, we'll look at our next three terms. Because we've seen all these terms. I think having the vocab yesterday was helpful. So these aren't all straight new. So, definitions of segment. We have all of this here. Do not write all of that down. Because a segment is what? It's a line with what? Because it doesn't extend forever. With two endpoints. It's a line with two endpoints. That's a line segment. It has a start and it has an end. And whenever we name a line segment, we have to put the line segment above it. All right. So like here we could have AB, or we could have BA. Those would be the same line segment. Any questions on line segment so far? Well, let's say I put a point C right here in the middle. AC, CB. Would all four of these be the same? No. Because with line segments, AC goes from A to C. Well, that's going to be different than from A to B, yes? And that's going to be different than C to B. Can we say that AC and CB are the same? Do I know what the distance from A to C is? Do I know what the distance from C to B is? So we can't say it. And that's one of the big things that's going to probably take a little time to get used to. In here for geometry, unless we know it's true by a proof, that we've gone through a mathematical proof and we're able to show that it's true, until we hit that point, we cannot say for sure that it is. The one thing that we can guarantee for certain right now is that if it looks like a straight line, it is a straight line. We can say that. We can't say much anything beyond that because is this a right angle? We don't know. I don't know what the measure of it is because the difference between 89 degrees and 90 degrees is so small, especially at this spot here, it is hard to tell the difference. So this here is actually close to 85 degrees. It looked 90 until I put that protractor right up there on top of it, didn't it? So that's the big thing, because even though it may look it in here, unless we specifically say it is, say it's 90 degrees, or we put our box. If you guys have seen rectangles where they'll put the little box to signify 90 degrees, then we cannot say it. Now, we will get to a point because of the proofs and stuff we go over here, we can actually start knowing and stuff because of the proofs and what we know about how shapes and angles work. Okay, that was my little tangent there. So here, for a segment, we can either say A, B, or BA. Those are the really only two, because anything that makes it a different length is not going to be the same. Okay? Now, on some of these here, especially on the test, I might just say name the following line segment in two ways. So A, B, B, A. Okay. All of this here is for ray. Now, you don't have to write that all down. A ray is a line segment with one what? Endpoint, and it continues on indefinitely in the other direction. That is a ray. Now, the main way that we name a ray is we start with the endpoint and name the point that it goes through. So if we look at this top one here, well, it starts at A, oops, if I can write, and goes through B. So this would be considered AB. A little bit. So it starts at A and goes through B. Now the bottom one starts at B and goes through A. Now we always want to start with the point that the end point is on the left. Even though the bottom one, the ray is going to the left, and we drew the arrow going to the right, that really doesn't matter. Because we're saying it started at B and it went through A. We're just signifying the direction it's going via the points. What points do we have? Is for the top one, is AB and AC the same ray? So for AC, it started at A, it went through my point C that I drew. Will it eventually go through point B? So are those the same? Yeah. So with rays, those work. But these here, AB and BA, those are not the same ray, because the start points are different. The end point is what they'll call them, is different. Y'all see how that works there? So with the rays, and really how we do the labeling above it, is where's the end point? So A, what's it going through? End point, where's it going? Is what we have here. Now, the last thing we have is opposite rays. If point C lies on line AB between A and B, then ray CA and CB are opposite rays. Well, what does that look like? A line. Opposite rays make up a line. Two rays going in opposite directions. They will make a line. So any line that has 3 points can be said to be composed of two opposite rays. Thank you. Any questions on any of this here so far? Okay.